Welcome to The Machine, a computer science education podcast from the South East Technological University of Ireland. I'm your host, Rob O'Connor, from the Department of Computing and Mathematics at SETU. We surprise dropped an episode yesterday following on from a very engaging presentation at Computing Week in the university. I was talking with Gary Keneally and Sharia Sanyal from Unum about how AI is changing the ICT workplace. That's available now, and I can see from the metrics that some people have actually listened to it. So thank you very much. I'm following that up today with another episode based around a talk that we had this morning from Red Hat software engineer Mark Campbell about getting started with your own AI. This podcast is probably more aimed at computer scientists than yesterday's. I was very impressed with Mark's AI demonstration that he performed on stage. He had a Gen AI system with a fairly useful data model all running locally on his laptop. And honestly, I couldn't have even imagined that a few years ago. So there were some great questions from students after the talk, and I thought, I've got to nab this guy for a podcast. We went for a quick cuppa and were joined by another Red Hatter, Dimitri Saradkis. Now, both of the lads are recent enough graduates of SETU, and I get a genuine buzz from seeing how their knowledge and skills are growing and their careers are progressing. And I learned a lot from our conversation, and they've given me plenty to think about when it comes to developing some AI systems myself. Now, in the podcast, we talk about Red Hat's OpenShift, some custom large language models, quantized datasets, and how someone would go about building their own AI. Towards the end, we get into some regulatory, ethical, and moral questions. Not too many answers, though. So, without further ado, here's Mark and Dimitri.
So, my name is Dimitri Saradkis. I am a team lead on a product at Red Hat called OpenShift AI, focusing predominantly on distributed training of large language models, any kind of model realistically, any kind of AI ML model. And I am an ex-applied computing, what's now known as computer science, I believe, student out of here. So a couple of years ago.
Excellent.
It's lovely to be back.
Excellent. Well, you're always welcome, and I hope the coffee is still okay. Mark.
Yeah, thanks for having me as well. So my name is Mark Campbell. I'm actually on the exact same team as Dimitri and Red Hat. And I'm an associate software engineer and former software systems development student.
Excellent. And you're only gone out of the place less than a year?
Since May, yeah.
Okay, great. So you're fair play to you. You came back to deliver a talk in the auditorium. Right, before we get into the contents of the talk, I just have to ask you, as somebody who's a very recent graduate, how did it feel to be, I won't say it was a packed auditorium, but it was a half full auditorium, which was very good, because it's hard to get students to go to anything, but it was still a lot of people, probably more people than you've ever spoken to publicly before.
Oh yeah.
How did that feel?
Yeah, so it was very weird because the last presentation I gave was for my final year project in front of, I think, 7 people.
Okay.
So that's quite a big jump considering. But I think I was more worried before I actually got up on stage, and then I was like, oh, it's fine. I rehearsed anyway, so I was okay in the end. Yeah,
well, I thought you did excellent. And you even fielded some tough questions too as well, which we'll get to in the next few minutes. So, right. So you're both working as part of this kind of OpenShift AI group. Could you maybe explain what is OpenShift AI and how does it maybe fit into the overall model of the kind of stuff that Red Hat do?
Yeah, so OpenShift AI is a platform for data scientists to train their models on in a cloud environment using OpenShift. So with OpenShift AI, they're able to gather all their data, prepare it, train it, and then serve it in a cloud environment or on-premise or even in a disconnected environment.
Okay, so is the idea behind this that I can have my own LLM? When I say my own, I mean a personal one or a corporate one. I don't mean one for me, with my own stuff in it. Although maybe, but I could have a customized large language model that might be fed with certain customized data, could be proprietary data, and that can be, I can use it in whatever context I wish to use it. Is that it?
Yeah, 100%.
Okay, so I'm not just relying on the publicly available ChatGPT, Bard, whatever you're having yourself models.
Nope, you can go from scratch.
Okay. And Dimitri, you're kind of nodding there. So do you agree with what he says?
Yeah, 100%. I would just add it's the whole system to manage the model lifecycle. So from the very, very start, from your data experimentation, your data collection, and engineering your data, getting your features and whatever ready in your data sets, the whole way through to training, fine-tuning a model, and then ultimately for inference then afterwards as well, to actually make use of the model. You stick it in front of an endpoint, like on a server.
Okay, now we hadn't originally, when we talked about how this talk might be structured, we didn't say that, and I'm just going to push you on it because I'm intrigued by it. So let's say, how does one go about doing this? So you talked about those steps there. What are those steps? What's actually involved in creating a custom LLM, large language model?
Yeah, so if we're taking LLM or any kind of AI ML model, realistically, the most important ingredient is your data set, your initial data set. Like, it doesn't matter what kind of what kind of flavor of the month model you use, what's the newest and coolest or whatever. If your data set that model is trained on is garbage, then your output is garbage.
Okay, so this is the idea. So the actual natural language processing is handled by the algorithm, shall we say?
Yeah.
But then the answers that it might give you to questions is fueled by the data set.
Yeah, 100%.
Okay, cool.
So yeah, the algorithm is what, like, quote unquote learns, whilst the data set is what gives it the knowledge, the knowledge underneath it all.
So again, if I go back now a year or so, whatever, and Facebook's first model was publicly available, and then it was taken by some people on, I think it was 4chan or 8chan, one of those places, and it was fed, I'm going to say, a biased data set, okay, and it turned into a racist homophobe. Mm-hmm. Is that what you're talking about?
Yeah, essentially.
So if I feed it silly information, it's going to give me back silly answers.
Yeah, 100%.
Okay.
Yeah.
Okay.
The issue with and people. There was a question earlier on during Mark's excellent talk where someone asked about, what if we just like exclude certain terms or exclude certain things from the data set? I think the issue, this question, I wanted to kind of get a little bit of an answer to, because I think it's quite an important one. What most people kind of don't realize is the size, just the vastness of these data sets. Like, so there's a particular kind of data set that we're working with, like the NASA IBM collaboration that Mark also mentioned earlier, and that data set is 250 petabytes. So like
250 petabytes.
Yes. So
okay.
250 million. I think you left out. You made it 25, not 250. So yeah.
Oh really? I thought the initial one was 25.
Regardless, 250 million gigabytes worth of data, right? So like, first and foremost, when you're actually trying to formulate your data set in the first place, like, the student earlier who was asking the question said, "Wait, what if we just leave out the terms rob and bank?" Right? Yeah. And you're kind of like, yeah, but perhaps that's not in that context, right? They're saying someone did rob a bank, but this is not exactly how to do it. It's how you actually create this data set to be perfect, when inherently human beings have biases, and we are, like, obviously inherently not perfect, right? So like, it's a really, really difficult problem to solve.
There's also kind of an inherent, to be fair to the student, he was a younger student, and I don't think he fully understand the whole thing about kind of natural language processing, because even as he was saying that, I was going to pipe up, well, what if you wanted to search for how does Rob, me, open a bank account?
Yeah.
Do you know what I mean? Like, years and years and years ago, I worked on some natural language processing, and the test that we always had was about Tiger Woods. So it was doing searches for Tiger Woods. Now, this is back in the day where you had a lot of keyword searches, and if you did a keyword search on Tiger Woods, you were as likely to get an answer about a big cat in the forest as you were a golfer. But of course, if you're searching for Tiger Woods, there's a much more higher probability that you're actually searching for something about golf than a big cat in the woods. So that's 20 years ago. So that's a long, long time ago that we were doing that kind of stuff. So I can imagine it's come along so much further since then. Obviously it has. Yeah. But let's just get back to the idea of building your own custom LLM. So you're talking about the data set is the secret sauce, or not so secret sauce, actually, because anyone will tell you that. Yeah. Okay. Right. So where do you go from there? Let's say I have a good data set, whatever it might be, 225 petabytes or whatever it is. Yeah. Okay. Where does it go from there?
So essentially it goes through like the initial training stage, where you'll train like a foundational model, and then maybe Mark might speak on like the difference between maybe a foundational model or like a base model, and maybe something like fine-tuning afterwards.
Yeah.
Okay, go for it, Mark.
So like the base model is kind of like the a general idea of what you want the future model to be. And so from there, you would fine tune it further for specific use cases. It's kind of like the foundational model is like a Swiss Army knife, and a fine-tuned model is more like an actual like physical tool.
Okay, so I'm trying to think of an analogy. So you're saying the base model is maybe trained on a general set of domain-specific data. So what I mean by that, let's say computer science, right? Just for the sake of argument, right? I'm going to train that on a bunch of textbooks, stuff from Stack Overflow, wherever the hell it might be. Or okay, maybe I shouldn't be doing it on Stack Overflow, IP issues, but we won't get into that. But let's say I've trained it on a general set of publicly available computer science data. But when you're saying you want to get into the fine tuning, this might be where you might want to turn it in the direction of a specific use case. Is it? So let's say I wanted app development, right, for building mobile phone apps, right, and I might want to put certain weightings on certain data sources to do with iOS or Android development. Is that it, or am I wrong?
Yeah, so the way that I would usually describe it would be like it's the for a foundational model or a base model, the knowledge that it has is broad but not very deep, right? So you're talking like an analogy in real life would be perhaps like a GP, right? Like a general practitioner. So a doctor that you go to, they kind of know a little bit about everything. But if you had like a serious skin condition, you'd go to a dermatologist, you'd go to a specialist, right? So the excuse me, the fine tuning aspect would be that you have like your vast data sets which like are scraped from the net. You've got Wiki Commons, you've got all of like the kind of like de facto kind of big massive data sets out there, and a lot of proprietary data sets too, which like OpenAI and so on and so forth have that their models trained on that they won't or haven't thus far released. Then to kind of, I suppose, specialize your model, that's when you aggregate a more like a data set that's like definitely smaller but much more specialized. So you can get like a data set that's created, say, from like ArchiveX, which would be all the like papers, PhD papers or whatever kind of papers like surrounding computer science or like biology or whatever, and then you like further train the model's weights and biases on that specific data set. So that becomes now a general, not a general model, but a more specialized model. So like it knows bits about like Python code, or it knows about like biology or any of the above, because it's like it's gone through extra schooling.
Yeah, okay, but that makes a lot of sense. I can see how that would work. So you get this base knowledge, then you fine tune it into a more specific area such that it becomes useful. Would that be fair enough? Useful in a particular context. Yeah. Okay, so where does it go from there?
So from there, it kind of depends on. There's a few other bits and pieces you can do. Like there's some new, I suppose, techniques. And we might get into, we might not, depending on which way you want this to go. But where you can add like ephemeral data afterwards, because like this whole process of as you like might guess, it's very compute intensive, right? Like it's not a. Leave the laptop on for 2 minutes and it's done. We're talking about like months and months and months of like multiple clusters, a cluster of servers essentially, running with the latest GPU technology, and just at 100% capacity for months on end, right? So it's not a trivial thing to put together. So if you want to train a base model, there's only a handful of kind of companies or institutions, shall we say, out there that actually have the capacity or the expertise and the knowledge to do so. And then furthermore, like to fine tune it is much easier. So you could actually fine tune it yourself. So what we're seeing, I suppose, is a shift from you have like there's a ton of open source base models out there, and then anyone can kind of like take one of those and fine tune it for their specific use cases.
Okay.
They can then further augment that by not, let's say, fine-tuning, by adding, turning it into a RAG application. So that would be like the addition of a vector database with which you can essentially just like upload any kind of, or upload, you could like throw any kind of smaller data set that you want to throw at it, vector it, like encode that into vectors, stick it in the database, and then the LLM can query that database akin to like your regular code querying any kind of database.
So you say that's what's RAG?
Retrieval augmented generation.
That's okay. It's another acronym in the world of IT.
Yeah, I think that's
another one we can throw on the heap. Okay, so and then from there,
so
where does it go? Then you have to, I suppose, expose it to the user.
Yeah, so it's absolutely useless unless you can actually go ahead and like query it, right? Like you have your model, you have to put in all this money on training it and all the data science expertise. You need to actually stick it on a server behind an endpoint and
query it from there.
Yeah, and then from there, like just hit it with prompts depending on the kind of model it is. If it's an LLM, you just prompt it using natural language. Other models out there, you need to prompt with like JSON key value pairs or whatever the actual model has been trained to do. LLMs are kind of the flavor of the month, shall we say? So you either, there are an awful lot of things. Let's say if you're taking like Stable Diffusion or Midjourney, some of these like image generation models, they will be a combination of models. So you'll have an LLM at the front. You would hit it with a regular natural language prompt, and then that will like it's kind of chained together with the actual image generation of aspect of the further model somewhere down the line in a little chain, and then that'll spit out your glorious image of Joe Biden scratching decks or whatever it is that you want to do.
Yeah, that's a very tame one, I'd say. Yes, I know what you mean. Right, so going from there then, Mark, what would you say is the next step?
The next step.
Or sorry, well, let me ask you, let me rephrase that question then, because this is the way that your talk went, and maybe we could bring it back to that, which is, so we're talking about these data sets are absolutely huge, right? But you did a demonstration on stage in front of the students where you downloaded a local language model. It was running off of your laptop. It wasn't connected to the internet, and you were able to query it and it answered questions. Now, if we're talking about data sets that are massive, okay, to use the parlance of our times, how do you get massive data sets to run locally on your MacBook?
So with the software I use, LLM Studio, it's connected through Hugging Face Hub, which is a kind of like a repository of over, I think, 350,000 open source models, which are just free to use. And from there, data scientists can quantize those really large models and make them smaller at the cost of, say, efficiency and maybe accuracy as well. And from there, using a tool like LM Studio or another one, Olama, you can run these models locally on your own hardware, like I did in the presentation earlier.
So you talked about quantization, about making them smaller. How much smaller can they be? I'm trying to get a sense of scale. So you talked about petabytes before. Are you down to terabytes, gigabytes? What are you into?
So there's a distinction to be made from the size of the data set and the model that pops out at the end of the data set, right? So your data set might be 250 petabytes worth of data, but your model could be 150 gigs or 200 gigs, right? Like that's still a substantial size to, like, especially for any kind of hardware to stick into memory. But in general, I suppose if you see like an awful lot of open source, it also depends on the actual size of the model. So you have like 7 billion parameters, you have like 38 billion parameters, you have 50, 70 billion parameters.
Sorry, I'm just making a jump here in my head.
Yeah.
So when you download, this is because I don't understand now, right?
Yeah.
So when you say you're downloading the model is a already trained on it. You don't need to download the data with the model. No, okay, so right, so this is the jump that this is where I'm learning along the way. Thank you. Right, so explain that to me then. So the model is its own self-contained trained data set, is it?
It's essentially, if you want to look at it, it's like a compression of the data set that's there.
Okay, yes,
right?
yes. So, but it doesn't have all the data behind it. It just has its trained version of it.
Yes.
Its own semantic link or whatever way it's done.
Exactly
things.
like you don't have access right now in your head to every single memory that you have ever lived through. Yeah, at the same time, the way that you think and the kind of knowledge that you do have has been learned and influenced from everything that you've done up into your life to this point. It's the exact same thing. It's a compression, and like it's lossy, right? Like some people have like photographic memories. Other people like me have terrible memories. So like you can't remember everything, but the model in itself is going to be like a much smaller size. Now, much smaller size is still larger. Like your regular kind of base model will take like a 7 billion parameter model, which is kind of your kind of regular Joe Soap model. They're still going to be upwards, like up towards 100 gigs in size. So like to run that model locally, you'll have to do some black magic. I'm not going to say the next word because it's a profanity.
Okay, no, but well, you can say that, it's fine. But 100 gigs is within the realms of possibility, but it's not going to be on your regular workday laptop, shall we say. But it could easily be managed by a local machine if you wanted to set it up for that dedicated task.
So that would be like a kind of regular size, regular 7 billion model, right? And what Mark was alluding to earlier was like quantization. Did he say that?
Yeah, you use that word. I want to go back to that, but if you just explain that again, because I think that's the key phrase, isn't it?
Yeah. So quantization is the like. During the fine-tuning stage, you can, I don't know how technical to get here, but
go for it.
So you have like 64-bit, right?
Yeah.
32-bit, 8-bit, right? Definition of like integers essentially, which is exactly what it is. So you can bring instead of training the model with like 64-bit precision, you train it with 32-bit, or you train it with 8-bit, or you train it with like 4 or 2. If you train it with 2, you could end up with a model that's like 2 gigs in size, right? It'll fit in your most Apple Watches right now. Now, the output would be atrocious, but probably better than Siri. But but in general, if you quantize down to, depending on the size of the model that you start out with from the start, and the actual like architecture of the model, how good it actually is, like whatever job the data scientists who put the model together did, the quantization like either makes it like completely unusable if you bring it down too low, or it brings it down to a usable level. So like the newest, a good example of this, I suppose, like, and I've not messed around with it yet, but the newest Samsung Galaxy S, whatever flavor of the month it is now, they have Google's new Gemini model, which would be like
it's on board, isn't it?
Yeah. Inbuilt in it. Now, like I said, I haven't used it. It might be terrible. It might be like fantastic. I don't know. But that's essentially it, right? You're taking a model that's absolutely massive. You're just making it smaller and smaller and smaller. And like the technology and tooling in around this is getting, it's like on a day-to-day basis. It's there's new stuff coming out every 5 minutes. There's a new research paper that like brings forward the field by what would have seemed like a couple of years ago that would be like 10 years, you know, and then all of a sudden it's like 3 or 4 papers, and all of a sudden we've got like a whole new field of AI that's you're able to run an LLM on your phone, like.
Okay, so I'm going to try and come up with an analogy here, and because I like analogies because it helps me to get complicated things clear in my head. So and correct me if and when I'm wrong. So let's say there's a data set, right? And I'm going to use a human example. And let's say the data set are the complete works, all the complete Sherlock Holmes stories as written by Arthur Conan Doyle. There's a number of novels and there's a number of short stories, right? And I read these, actually, when I was much younger. I read all of them, okay? I have an internalized memory of all of those stories and all of those novels. And I know the general gist of the adventures of Sherlock Holmes and Dr. Watson and etc., etc. And I might remember some specific details. However, if you ask me what happened in this particular story, I won't remember that, and I will have to go back to the original data set. So my internalized version of those stories is equivalent to a model. Would that be right? But the data set is all of the original stories in their original form, and they're off out there.
And then some.
But I'm just talking about in this particular context, shall we say, right? A quantized version of that would be, let's say, because it's not the same data set. I can't transfer my memories into you or your memories into me. But if over time I forget some of that stuff, I still might have some of the general gist of it, but I'm losing some of the fidelity of the detail as to what happened in A Study in Scarlet, for example. Is that ish?
Be more akin to you being
you won't insult me, so
it'll be more akin to you being drunk whilst you read it, right?
Okay,
so you have less of a grasp of actually getting in the full information because your like senses are impaired or whatever, you know. Maybe drunk is probably a good example, right? So like you're not working to your optimal capacity, right?
Oh yeah, so it's not even like even asking. Let's say I'm sober, I remember all of this. I have a feed of pints and a few whiskies or whatever it is. I still have that knowledge there, but it's fuzzy. It's fuzzier.
No, so now you had a feed of pints. Now you start reading it, and how much do you remember whilst you have a feed of pints?
Okay.
So it's a slight subtle difference.
Yeah. Okay. I think I get you.
But
yeah.
it's you could probably flake through that data set like after a feed of pints, like with relatively little like hardship for yourself, because you're like, right, you don't really care, right? You're having a few of pints, you're like, oh yeah, whatever. But
the
how much of
quality
it?
isn't
Yeah,
there.
but the quality isn't there.
Yeah,
right?
I get
you could probably go through more of it at a much quicker rate, but like I said, like the actual like what you take in is not there.
Okay, so the quantization then could be, okay, I'm just going to skim this. As opposed to do a deep reading of it. So to take the alcohol out of it. And Mark, you're reading, just because I don't want everyone to think that we're getting people drunk here. Okay, because that's a lovely Irish stereotype. Yeah. But you're agreeing that's kind of the way to think about the model and the quantization of the data set.
Yeah, I'd reckon that's a good analogy. Another one I could think of is kind of like, say, as a child, you're learning, but it wouldn't be the level of comprehension would not be the same as I'm an adult now. I can read a piece of information and I could recall it back to you pretty well in comparison to how a child could A, comprehend it, and B, give it back out to me.
Okay, that's a much better example.
Yeah. Or even like,
and these kids aren't drunk.
Yes, that's better. Yeah, we're not bringing alcohol into it. Okay, I get that idea. Yeah, that makes a lot of sense. Okay, right. So I'm going to ask you a kind of a bigger question, Mark. Why would I want to do this? Why would I want to run a local large language model on my machine? If it's going to be computationally intensive, I'm probably going to have to download a large data set. Why on earth would I want to do that? Can I not just use ChatGPT?
Well, I mean, the way I look at it is, they're not exactly huge either. It was like I think the one I used today was 4-bit, and it was also I think 3 gigabytes in size.
Okay.
And that ran relatively efficiently on my laptop. It might be different for other people, but I know on my computer at home, it is actually a struggle to try and run any of these large language models. But why someone would go and interact with running these locally, say there's data privacy. Everything I would throw toward that model is all kept locally. As again in the demo, I was disconnected from the internet, and it was able to dispel that information to me when I was asking it to write a Python script. And not only that, it's like, so when you use ChatGPT, it's always constantly learning off of you, and so that information isn't exactly yours anymore. It's more, it's ours, kind of situation.
In a public model, like, or a model out there that we don't necessarily know how it works.
I wouldn't even say it's ours. I'd say it's like
OpenAI's.
It's
OpenAI's model.
Spade a spade here. There's a reason why the company valuation is is where it is right now. And realistically, it's probably Microsoft's.
So again, if I can go back to an analogy, let's say, for example, I wanted to set up an LLM for SETU. Right, that I could use, or let's just say for me, and we could extrapolate out to the organisation, right? And let's say I had a lovely server sitting up in my office, which I don't. Okay, I have an aging MacBook that I really need to it needs updating because the fans are going nuts on it. Okay, but let's say I had a decent server up in the room, and I wanted to get one of these local LLMs, let's say LM Studio. Okay, and I downloaded the base model, but then I wanted to train that with or tune that with some student information, which is private. I don't want it being publicly available. It might be things like grades or progress, but equally it might be sensitive information about, like, maybe a student has a medical issue or something like that, blah, 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 blah. But I want to be able to query it because I forget that student has a medical issue, and 2 years later they come to me with something, and I'm just able to query ChatGPT, or not ChatGPT, my LM Studio, and oh yeah, they have this issue or whatever. Is that the kind of, to me, that sounds like a reasonable use case. Does that sound fair?
Yeah, 100%. And a tool like LM Studio actually offers a kind of like a server endpoint. So I went through the example. You can have it running on your own hardware, LM Studio, with running a local inference server, and from there you can ping it just like with the ChatGPT API. I think it gives you some examples too. Like it'll have a Pythonic way of kind of talking to the LLM through this server, all locally.
Okay, so and you can imagine how that could be extrapolated out to any organization, any business. Right. So let's get into some of the kind of the questions that students ask. I can see why this would be beneficial. I can see this as being a potential future for the way some generative AI might evolve over the coming years. Some of the student issues were kind of conspiracy theories, like what if they do this, what if they do that, what if it tries to rob a bank, okay, which we won't get into. But there were issues about regulation, and that was brought up. And where do you think this is going? Because I know there's a bit of a scramble. There's a kind of an EU model or an EU viewpoint. There's a US model. There's a kind of a British model that is somewhere. I think the Chinese have a different model or different view on this. So where do you think the regulation stands on this type of stuff? So Dimitri's more deep into this.
So that regulation is it's a tough one, right? Because like at what point do you actually regulate it? Right now, there, like I kind of mentioned earlier on, there's only a handful of like institutions that can actually do any of the training and like have the expertise to create these models, like these base models. So do we kind of try and regulate these models or these institutions, organizations? Some of which are like the like your Google's, Metas of the world, Mistral, which is a company based in Paris. But then there's other companies as well. Like Falcon is one of the largest and top performing models out there, and that is a Saudi state paid for model. So like, for regulation to occur, we kind of need to know where you regulate it. Like, at what stage of the model lifecycle do you regulate? Do you regulate the actual creation of the data set? Do you regulate what the algorithm is? Do you like set some kind of a benchmark as to like if the model performs above this percent benchmark, then you have to have X, Y, and Z tests surround it. Like, it's really, really difficult to kind of like figure out a kind of regulation surrounding it, but B, if we do go like the push towards regulation, which it should definitely be regulated, but then we need to have everybody sign up for it. So like every country needs to, and every country and every organization within every country, which like if you look at the world right now, like not every country kind of gets on with each other, right? So like trying to get them all to coalesce around a certain set of standards or ideas, which like in an industry that's worth this amount of money as it is right now, how are we going to do that? I don't know. We can hardly even agree on what's the best coffee at the minute. Like, so it's a difficult one. The only kind of model that I know of that is like I think I mentioned to you earlier, Rob, is like Adobe's Firefly image generation model. Is the data set that's trained on and that's created from is 100% owned by Adobe. They have like all of the IP surrounding the data set. So like that's probably, if I was to wager, that's probably where it would go, would be like data set creation. And this is why a ton of companies like Reddit, for example, all of a sudden like, they've turned off their APIs. They have data sets which they were just like letting open to the public. Anybody could use like Reddit API and come up with anything. But now this is like gold, right? This is like a gold mine. So now you're going to have these companies are starting to realize that you're going to have to pay for access to these data sets because just I suppose the amount of money that's involved. So regulation is a sticky place.
I mean, you're getting into a whole thing about intellectual property and how that's valued and protected, and I don't want to get into. I mean, I'll use my Sherlock Holmes example, right? Let's just even say I wanted to feed an LLM the works of Sherlock Holmes. They're all in the public domain, okay, right? But let's say I wanted to feed it the works of Donal Ryan, who's still an author today, and hey, write me a story in the style of Donal Ryan. I would have a huge ethical issue with that. You know, or whoever, or Megan Nolan, because I'm reading her at the moment.
Right.
You know what I mean? Like, so taking their novels, which is their intellectual property, feeding that into some sort of an LLM to then create something in that style. That's an issue.
It is an issue, but also I'm just going to play devil's advocate.
Oh, do go for it. Go for it.
Is it that different to what we do as human beings? Like, so you're like sitting there and you're after naming out a couple of authors that you've read, right? So if you turn around in a couple of years' time and Rob decides to write a novel based on whatever, like your influences are going to be from the stuff that you have read already, right? So like, how different I understand obviously there's like the human biology part and then there's, you know, the machine and algorithm or whatever that we created, but there are similarities there, right? There most definitely are.
I suppose, right, again, playing devil's advocate here, right? And I'm going to use music as an example, right? Because it's a bit easier to get my head around a song and I have a bit more experience with this. Like the world of music, pop music in general, is everything is derived from everything else, okay? But there's a kind of a progression. But generally speaking, somebody has to have some sort of talent or work to create a piece of music. Whereas if I use one of the models and create a song in the style of Drake, or there's the Johnny Cash one that's going around. Yeah. But any fool can do that. And I'm not seeing the artistry in that. And just from myself personally, do I really want to listen to that? Am I going to get any deeper understanding of the human condition from something that a machine has created? Maybe I will, maybe I don't, but I know what you're getting at. It's a philosophical question. It's kind of
So even from that perspective as well, like I don't know if it's currently possible. I doubt it is to like just say like give me a number one best selling song and the AI comes up with everything. You're going to need to like give me a song based on like with this amount of bars per beat or whatever beats per bar, and then like these are the lyrics that I want you to put in the style of X, Y, and Z. I think, you know, actually maybe this other person would do a better job at the local harmonies or so on and so forth. You're going to have to like really construct it together and know a thing or two about like music composition, which I obviously don't by my shoddy example there. But there is a certain like creative aspect to it. Yeah, look, I'm not saying that like this is the way that I like it to go. Either like I have no musical talent and I thoroughly like enjoy listening to people's music, but like that's not to say that I like at some stage in my life do I think like, hey, here, look, I can't sing, right? My voice sounds like two bags of cats being bed together. But like, if I was to, still, you know, I might like fancy like myself as a lyricist, right? Yeah. And I just don't have like, I'm just not fortunate enough to be born with you know, the silky tones of, I don't know, you know, BB King. So like, yeah, I'm at a distinct disadvantage. I'll never create a BB King song because you know, I just don't have that.
No, but you might create a Dimitri Saradkis song.
Ah, yeah.
Do you know what I mean?
Yeah,
like
nobody's going to want to listen to that.
How do you know? Yeah. You know, I suppose these are the bigger questions. I don't know what the answer is, and I'm not suggesting that I do, but my instinct is kind of veering away, certainly for creative works, creative artistic works. But equally at the other time, like, I mean, I spend a huge amount of my time doing what I call spreadsheet work, which is boring, menial tasks. If I can use an AI that might automate or speed that up, I don't have a problem with that because I don't. But if I want to create something, I don't necessarily sure I want to use it. Now we're gone off topic from talking about local LLMs there, but you know what I mean. Like,
so if I was to ask you a question, then Rob, would you have an issue with an LLM coming up with novel science? If it was like to I don't know, create a new drug, let's say, for example, all of a sudden we had an LLM that came up with some novel science based on previous works of art that were carried out and done by humans, but the LLM, now we have a cure for cancer. Is that, do you have an issue with that creativity? I'm sure you don't.
Well,
right?
no, I wouldn't. But you see, it would still have to be tested.
Oh, 100%.
It wouldn't just go, okay, off we go. That would then be taken, go through a rigorous scientific process, blah, 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 blah. No, I can totally see that. Yeah. But that's an inference of maybe multiple data points to, hey, there's this pattern here that maybe you haven't seen. Have a look at this. But it would have to be queried as well, because this is the other thing that I think is misunderstood about generative AI, is that they're not kind of self-starting, generally speaking. Do you know what I mean? Like they don't just take control and do things. Not yet.
No. Like, when you boil it down, they're just a probabilistic machine. That's all they are, right? It's like I'm predicting. Like an LLM just predicts the probability that this next word is like fits after the last word. That's all it is. Like when you take any of those LLMs, that's 100% what they are.
There's a phrase used, a stochastic parrot. I love it. I absolutely love it, and I probably use it at the end of the time. So I'm conscious of time, so I'm going to kind of feed you one last situation. And again, this is I'm not trying to be alarmist or anything like that, but I'm mindful of that. We as humans need to have our own internalized set of information and I suppose critical skills, which we develop over time. And I don't just want to outsource everything to an LLM and say you don't need to learn anything going forward, because first off, I'm an educator and I'm putting myself out of business, but also I believe in kind of that you need to have your own critical faculties, otherwise you are just the stochastic part. So I want to give you an example, and this kind of will tie into the demo that you did, Mark, in the auditorium earlier this morning. So I had a first year class last semester. It's Computer Systems 1. So actually you both would have done a version of this a number of years ago when you were here. So we did a lab, a Gen AI lab. We were just kind of mucking about with some of the tools, trying to show them in a more, I don't want to say controlled environment, but in a more directed environment. And one of the tasks that we did with these first year students was get them to create a rock, paper, scissors game in Python using whichever Gen AI tool they wanted to use. Most of them used ChatGPT, a few of them used Bing, which is it's called Copilot now, but I think that I don't think anyone else used anything else. They might have, but that's what they did. Okay, and for most of them, there were a couple of things that I took. Most of them it worked. They fired it into one of the Python tools. I think they were all using Trinket, the online one, because there was nothing needed to be installed, and most of them it worked. But there were two things that I kind of took away from it that were interesting. One was the variety of the results that they got, even from the same engine.
So same model backing both of those.
So I asked ChatGPT, create me a rock, paper, scissors. You ask the same question and we get different results, ever so slightly different results. So there's a certain randomness there that I think is kind of interesting. Okay. And the second one was I did that lab twice with two sets of first years, and in both classes, and there's I'm going to say about 25 people in each room. It might have been 22, it might have been 26. I can't remember, somewhere around that. There were a number of versions that didn't work, and as I looked at the code, I went, okay, well, I can see why that works. And actually in two of the examples, I remember the issue was there was a stray exclamation mark, which is legal syntax, because strays exclamation mark is often used as a logical not operator. Okay, and it was in the wrong place, which was causing it to not work. There was a couple of them where it was not compiling, and I think there was lines commented out that shouldn't have been commented out. But again, that's just is it a hash symbol on Python? I think there was a stray hash symbol, which again is legal syntax, but it's just in the wrong place, and from a probability point of view, it's put this character in the wrong place. So I just thought that was kind of an interesting one, because I was able to solve it by looking at it, not because I'm a particularly good programmer, but I have internalized certain coding rules. I go, oh, I know that's your issue there, we'll fix that, and now suddenly it works. But I'd wonder if it's the first years who didn't know this, they're just looking at no, doesn't work.
Yeah.
So I was kind of interested to get your comments on that, because like Mark, you generated some Python based on your personal your internal local version of LM Studio, and that's great because you know how to do that.
Yeah.
But if you didn't, it's just gobbledygook.
Yeah, exactly. And it kind of ties into why you kind of already need to have an idea of what you want to ask. So like, sure, I know my way around Python, and I know exactly how to ask the question to the AI model. I want you to generate this Python using these libraries, whatever I'm looking for. But again, it might not give me a correct answer. It might give me something that kind of half works, but then I have to go in and I have to go fix it. It's like multiple times I've tried to automate certain things that I'd normally do, like moving files from one directory to like a server and everything, and I'd be looking to implement certain things. So I'd ask, hey, how would I do this, and then give me a answer back. Might not work, but then I could go in and I could play around with it, fix it further.
But it gets you off that blank page. Yeah,
it's kind of like it's instead of starting at like 0, you're starting at I guess halfway there almost. And it's a better starting point when you're only doing it just to do a menial task anyway.
Dimitri, your thoughts on that?
Yeah, 100%. Like, you can't just, they do hallucinate, and they do hallucinate quite wildly as well. Hallucination being the term used for like when a model just lies, right? It's a nicer term than lying. But
friendlier.
Yeah, friendlier. But yes, at the same time, you have to like be, Mark said it really well there, when you kind of just, instead of starting on a blank page, you start at like 30, 40%, 50%. You have to be able to critically look at what the model has put out. You have to have, like, in the case of like the code example, you have to have your own knowledge of like the kind of fundamental coding principles or whatever, so that you can actually spot what's going on and you can go off and correct it. The other thing that we didn't touch on earlier, and if we continue down the path of just trusting models left, right, and center and whatever their output is, would be model collapse, and we don't have that much time so I'm not going to go into too much detail, but
no, but you can mention what it is, because it's a nice thing to think about. I'm not trying to be a doomsayer, but it is. I know what you're getting at here now. Yeah.
So if you were to just trust whatever output of the model without like, so if you didn't do any of your own kind of like research, or like you didn't do any of your own learning, shall we say, you didn't know how to code whatsoever, and you just took whatever the model said for granted and did this over and over and over again, let's bring it back to what actually model collapse is. So like the models themselves are trained from like as we've already mentioned, like vast swaths of data that's out there. If human beings stop creating the data to feed these models, so say for example, instead of me going to like it or not, right now the internet is run by Google's ad algorithm realistically, right? So if you have a website, you get paid to keep your website up online by Google Ads, essentially, right? Or Meta Ads, but like predominantly, well, both of those companies. So if someone, instead of Googling something, and we know how crappy Google has got at like answering your specific queries, it just sends you through reams and reams of ads right now. But if we just asked an LLM that, and the LLM brought you the answer straight away, then you don't get the ad revenue from your website for the clicks on your ad website. So what's the motivation for you to go off and continue to like create your helpful website about like Python code, or about whatever it is that is your discipline?
Yeah.
There is no kind of monetary solution out there. So in a world then when we're getting back to not being able to trust everything that an LLM comes out with, in a world where estimations are somewhere between anywhere from 40 to 70% of it could be anything realistically, of the hallucinations are just that, right? They're just like down and utter lies. If human beings stop producing quality information that's peer reviewed, or that's that you just like actually checked yourself, and we instead devolve, I would use, into a world where we only have data that's flawed inherently because of the hallucinations that the LLMs have, and this is the only data that's being created, then we end up in a scenario where further models can only be trained on this already flawed data, like in a downward spiral, and we all live in a Mad Max world. I know what you mean.
So there's kind of stagnation. If we're humans not still creating and moving forward, everything just stagnates.
Yeah, it'd actually be worse than stagnating, I would say, because we're not actually moving the needle forward, right?
Yeah.
Like what we've done, like my mother was around when there was no electricity, right?
Yeah.
Like, she's not that old. I'm not going to say how old she is because she'll kill me. But, right, but like in the grander scheme of things, like human kind of like humanity has moved at a really, really rapid pace, and that's true. Like innovation, it's true. Research, it's true. Like I suppose if you take like all of science, you could together, you could kind of look at it as like one single organism, right? Like everybody, like the whole thing working together to collectively pull knowledge forward. If we stop doing all of that, because we're just relying on an LLM to give us the answer based off what, like 70% correct of what we already know to date, then we stop, right? And we don't just stop. The 30% of the factual or the non-factual stuff enters the data, enters the new data sets, and it just drags the overall quality down. So not only do we not get better, but we actually like progressively get worse. So,
Or it'd be like answering questions. Like if our computing knowledge stopped at 2004.
Yeah.
And answering questions 20 years later based on data from 2004 or 1984 or whatever it is you're having yourself. And again, that's computing. We could apply that to any discipline, no matter what it is.
Every discipline. But also with 30% of that data being wrong. Factually wrong.
Yeah,
right? So then like the next stage then, if you already start at 30% and you get 30% of the next batch subsequently, like you're just down, you're like...
It's compound interest.
Yes, yeah. I don't know what a tracker mortgage is.
Excellent. Look, Dimitri, Mark, thank you so much for your time today. You've been absolutely fabulous. And Mark, thank you for coming in and chatting to some of the current students, even though you're just an ex-student, barely a wet week yourself. Your card is marked. You will definitely be back. If somebody wanted to find out more about you, the kind of work that you're doing, or hit you up for, I don't know, an interesting proposal, what's the best place to get you?
For me anyway, it'd be LinkedIn 100%. The easiest way to get me, just Mark Campbell.
Mark Campbell on LinkedIn.
Mark Campbell on LinkedIn, yeah.
Okay, and Dimitri, yourself?
Me, same as Dimitri Saradkis. If you can't spell it, yeah, you probably can't.
Yeah, I'll put links in the show notes for this here as well.
Excellent. So Dimitri Saradkis on LinkedIn as well. Yeah, I don't do anything with the rest of the social media. Yeah, and they're all evil.
And your mental health thanks you. Yeah. Okay, lads, thank you so much. Thanks for your time, and we'll talk to you soon.
Rob, thanks so much.
Thanks for having us.
Pleasure.
Thanks for listening to this episode of The Machine. If you liked it, please leave us a glowing review wherever you listen to your podcasts. It helps us to grow the audience, and it also makes me feel good. Will we have another episode tomorrow? Who knows? I'll see what I can do. In the meantime, you should find some links in the show notes to where you can find out more about Dimitri and Mark, and I'll also include some links to some of the tools that they referenced during the conversation. Okay, Shlán go fóill.